Hello, my name is Peng Xu, and this is the very first session uh, for me to deliver some hands-on experience to you. So today I want to walk through the very first project in self-driving now degree, the first term, uh, namely the landline detection project. So here it's Jupyter notebook you will get from the GitHub. I will walk through this project one by one item by one item. So not only about the project itself, but also how you can use some uh, tips in. Uh, I think in it's very would be useful in any of projects that you will do in the future, like uh, how to do some unit test with visualization, how to tune the parameters. Uh, this will give you some hands-on experience. So, firstly, read a little about the description. So, this project will use some traditional computer vision techniques to detect the landlines. So, in the end, it will show a picture like this. The picture will show a piece view of the road. In the road image, you will see some cars, some white lines, some yellow lines. So your job is to detect where the white lines and the road lines, which the car, the eagle car, means the car you are view from. Um, can see the lines. So firstly, you will uh, use some OpenCV library to uh, get the landmarks, get the white and yellow lines, and then you will process it to two single red lines. And this will be very useful when you want to guide the steering, how to like turn left or turn right or keep the current direction with information of this detector landlines. So firstly, in the first cell, you will see you need to import some very useful uh, packages. So in the future, you will be very familiar with these libraries like matplot. It's very useful for visualization in Python. So firstly, you need to make the or enable them. So you need to run it, and it's working well. So the call package would be the CV2, and the matplot image. Here we use it as MP img. This will be responsible to load some image. So in the second cell, you will see an image is loaded by this function mpimg.imread. So here it's very simple. Use this function to load a test image. In this image, you will see the landlines, and we haven't done anything about it. When you load it, you can check some information, some basic information about the image, like what type is this loaded variable, and what's the dimension of this image. So its width and height are 540 and 960 respectively, and has three dimension like RGB dimension respectively. So continuously, we will use CV2, some very useful function from OpenCV to do some like color selection, region selection, and draw lines on an image with given endpoints, and also add weighted and CV color to uh, do some like grayscale or change the color, so it would be helpful for more operations. So we also enable the cell2. It is functioning well. Continuously, those are very important helper functions. We will check the function one by one. The grayscale is very common in image processing. Like sometimes you need to uh, separate some features from an image. The very first thing is usually to convert it to a grayscale image. So this function will do this job. CV2.convert color. So this parameter means it is from RGB to gray. So after that, this image will convert it from 3 dimension to 1 dimension. And Canny, it will apply the Canny transform. If you have already listened to the lectures, you may have some uh, knowledge about this technique. And also Gaussian blur applies the Gaussian noise kernel. So it's kernel size, concise, and region of interest. So because the full image, it is not everything that we want to process with. Uh, if you can find a small piece of the region that uh, will affect our uh, our operation, you can crop it to uh, the final region we will operate. So in this way, it will make our life so much easier. And draw lines. So this function, it will accept some lines you want to draw with the color you also uh, give it as a parameter, and also the thickness. It will traverse each lines in the inputted lines. And find the age and use the line function from the OpenCV also to draw the lines from the beginning to the end with the color and thickness information. Yeah. So in the end, we want to draw the lines from the left line and also the right line. So this function hue lines will output some information from a Canny transform. it will return an image with hue, lines, draw. And after that, the last function is called the weighted image. So it means because in the end we want to uh, overlap overlay the original image and the process the information together to create a new image. So this function is uh, telling the OpenCV that how much weight I want to keep the original image and how much weight I want to uh, put to the processed uh, image information and then uh, combine them together. So we also enable this cell. Then test image. The test images are in the test images folder. There are several images with different kinds of uh, difficulty to detect the lane lines. There will be images with only straight lines and also images with curved lines. So that may challenge your solution in different ways. So we also enable it. It runs well. So we use the OS package to read the images. So this function means it will read the to list the image names as a list from the folder. And after that, we want to build a lane finding pipeline. Uh, it means that we put all the proper image processing uh, procedures in one function uh, in the end. But before that, we will test it in this cell. If everything goes well, we will put it in one function. So firstly, we get all the images, all the test images with this function, as mentioned in the last cell. And the pipeline is we traverse all the images in the list. Firstly, we read the image, use imRead with path and its name. And then we grayscale it, means that we convert it from the RGB format to a gray format. So if you want to debug it, maybe you want to uh, show it, visualize it. So it will be done by matplot.imshow because it's gray. So the CMap will be given the gray parameter. And don't forget to put PLT show. So as long as you have this line, matplotlib inline, it will uh, allow you to it's here to show the picture in the Jupyter notebook. Then the cone size. So usually there are some common parameter we use. Here we choose 5. We can also play with other parameters but it must be an odd number. Then we apply the Gaussian blur function on the image. We will get a blurred grayscale image. You also can show it, visualize it after that. And then we use a low threshold and a high threshold so we can minimize the range we uh, process. The edges. In this way, we separate the image, the rest of the image with our interested part, which means the edges or the landlines. And we reduce the region of interest to make our life easier. You can play with points because here we just do it manually. You observe the picture and guess where would be the boundary of the region of interest. You play with it and visualize it, and you find the best choice. Yeah, it's not some elegant way, but it works. And here we have some parameters we want to use. You can also play with them, and that is also a job which can be called parameter tuning. That's also very important. So you will get landlines and you create a new picture which is called the land image. So in this image, you only show the landlines. In the end, you want to convert it. No, you want to combine it with the original image. So in that image, you can uh, you can see a very obvious red land lines. So it can guide you with the next uh, steering angle. So we also run it. It works well on each test images. The first one, yeah, it matches with the original lines perfectly. Second, it also works well. Third, works well. Fourth, works well. Fifth, and sixth. Let us go back to the original test images. So it's like this. Here we only have the one of the test images. So it seems to be enough good. And to make it more vivid, we want to apply it on videos. Videos is nothing more than a series of frames or images. So if we can apply what we have on each frame or in each images at with a time step, and then combine them uh, into a new video, it will be more vivid. So to make this, we want to have these two libraries. The first library or the package is responsible to create the video or convert the images to the video. and the second is to display the two in Jupyter Notebook. So this cell is just a copy paste from the last cell where we were doing the test, and now those code are in a function which is called process image, because we want to use the function name as a parameter into the MoviePy editor video file clip. So it will do all the pipeline and return the final image. And I'll put the name here, what will be called when it is output. The video clip is called clip 1. First we enable this cell. Then in this cell, it will use clip1.fl image, and the input parameter is function name of the pipeline. And this function expects color images, so you need to notice that. After that, it will spend some time to process the images and convert it to a video, and magic just come. You will see that. Okay, it spent 12.9 seconds. So here, use this language is just a dummy command. It's not very complex, but it makes your output more vivid. So here you can see what you have now. So from here until here, I mean, you have almost finished all the requirements of project 1. So now you may want to check the rubrics. So GitHub Udacity. So I mean, it's very important to go through the rubric of each project before your final submission. The review will go over each points to judge your submission. So here you need to finish the Jupyter Notebook, what I just showed with you, and you need to finish a write-up report, either in PDF or Markdown. So you can write down what you think about the project, how you finish the code into that in a clear way, I think. And you need to output the video. Hopefully you can have the ability to do that after this video. And it's very important the left and the right lens lines are accurately annotated throughout almost all the video. So it's not necessarily completely all images, but uh, obviously you need to uh, meet this requirement uh, in most images. So in the video, it will show uh, that it will give a very accurate suggestion about how to do the next driving, next steering, like turn left or turn right. So it also required to visually correctly. Yeah, it's very important to describe uh, what you have in the end of the coding and maybe have some suggestions to uh, for the future improvement, not only for yourself but also uh, for the future for other projects. And I think that's all. And this is the very first project of your now degree. I hope you enjoy it. Thank you very much. If you have any questions, please feel free to shoot me an email or shoot me a question in the living room in the live session.